Okay, so we discuss about the current in a current carrying conductor, right? And this is completely complete topic of electric current that is going to be included in your AS, right? Because the
Yep.
typical section and the typical question from the electricity section is the circuit diagram, that is DC circuit. So first chapter is not much very difficult, but the second one is a very difficult one, that is completely related to the diagram and the formation of diagram, how to solve the circuits, how to connect all the theory that you studied. So that was the difficult part. Otherwise, this first chapter is very simple. That is not much very difficult, right? Okay.
Yeah.
So next section is related to your potential difference, right? First section is electricity, and second section is potential difference. And I hope you already know about the concept and the difference between potential difference and EMF, right?
Yeah. Yeah.
Okay, so you know about the potential difference. So first of all, you know that we have to write the definition first, because now definition is very much important. That will give you free marks in your exam with every question. So that's why always write the definition before any topic. So basically, if we talk about the potential difference, so EMF is completely linked with the circuit or with the source. We can say that the voltage is completely linked with your source. But for potential difference, your voltage is completely linked with the components that are connected across the whole circuit, right?
Yeah.
So we can say that the potential difference across a component, because we know that we when we are going to connect voltmeter, so we always connect voltmeter in parallel, because with each component we have to measure the voltage individually, because current will always same in series combination. So that's why we always connect circuit in series combination. But sometime, depending upon the situation, we connect some devices in parallel combination, and to measure the voltage, so we need to connect voltmeter in parallel combination with any component. So the potential difference across a component in a circuit is defined as the energy transferred per unit charge any definition. That will be easy for you in exam, because there are multiple definition for potential difference. And EMF is also going to be included in this chapter, because now we have to discuss about the internal resistance of battery plus external resistance. Now we study the extended topics. So this is the definition for potential difference. And next you need to know about the symbol.
Okay.
So you know about the symbol. V is the symbol for potential difference. Also for the SI is same, that V for potential difference, V for the SI unit voltage or the SI unit. So V is the symbol for volts also, right? Or in journal, if we want to write, so we know
Yep.
that the energy transfer per unit charge, so volt can also be written as joules per coulomb. So that is the additional information, because sometime in MCQs or in any question they, yeah, write joules per coulomb. So we need to know that this is also a unit of voltage or volts. So that's why joules per coulomb, and simple words the volts. But generally we write volts, but if we talk about the formula, so it will be joules per coulomb. And we know that potential difference, or if we talk about the voltage, because we are only talking about potential difference right now. So when we are talking about potential difference throughout the circuit, so in series combination, potential difference will always shared between all components, right? So I will also write the same point,
Yep.
that potential difference in series combination always shared between all the components. We also discussed this concept in the combination of resistance and parallel, right? So
Yeah.
at that in that topic, we discussed this concept that potential difference is going to be divided in series and current is going to be divided in parallel combination. And the next thing is, that we use voltmeter to measure the potential difference, and we use ammeter to measure the electric current. So that is also a basic knowledge. You already know about that. Okay. And if we just simply draw a diagram to just refresh our concept related to the potential difference. So let's suppose if we are using a battery over there, and the battery is of 12 volt, let's suppose, and there are two components connected in the circuit. One component is the bulb, which is connected over here, or the lamp, we can say that this is the lamp. And you also need to remember all the symbols that we use in electricity section. So what is the second symbol in the diagram? The rectangular box. What is the name of the
It's
component?
gonna be a
Yes, it is a resistor. Good. So this is a resistor. Are having a lamp in our circuit. So it means our potential difference is going to be divided between these two components, and 12 volt is the that we are receiving from the main source or the battery. And let's suppose this bulb is going to be consumed 5 volt, and rest of the voltage or the energy is going to be consumed by the resistor, right?
Yeah.
And if we talk about the parallel combination, so in parallel combination, we know that voltage will divide equally, uh, or voltage will remain same throughout the circuit for the parallel combination, right?
Yeah.
And the next thing is the formula. If you want to calculate the potential difference, so what is the formula to calculate potential difference?
PD equals to
Hmm?
V divided.
V divided by.
No. V equals to IR. So potential difference is gonna be
Hmm.
I multiplied by R. So it's gonna be the current multiplied by the resistance.
Okay. But if we only talk about the potential difference, because that V is equals to IR is a statement linked with the Ohm's law, right?
Yeah.
Resistance involved over there. So there is a concept of resistance, right? But let's suppose if you only want to write the formula for potential difference without the influence of resistance over there, so your V will be equal to, because in definition we mentioned that the energy transfer per unit charge. So the concept of energy is like a work done in moving a charge, right? Because energy is basically ability to do work. So if we have energy, so then we are able to do work. So that's why V will be equal to W over Q, right?
Okay.
And you can also identify this formula from this SI unit, joules per coulomb. Joules is for the work done and coulomb is for the charges. So this is the formula for potential difference, right?
Okay. Got it.
Okay, so this is the basic formula that we already discussed, and this is the formula W V is equals to W upon Q. And the next thing is which is related to electrical power, right?
Yeah.
So we also know the concept of electrical power, because now we are only talking about the basic terms. We are only refreshing the old concept. So next term is related to electrical power. And for energy, we know that energy is the ability to do work. And when we are talking about the power, so power is rate of doing work, right? rate of doing work is known as power. And this is journal definition because we know that if we are doing talking about electrical power, so we are going to drive formula for electrical power. And if we are talking about some other type of energy, so definitely there will be some other type of power over there, right? But the journal concept is simple: rate of doing work is known as power. And your formula is also simple: P is equals to W upon T. This is journal formula, right? And if we want to convert into the electrical one, if you want to write the formula for the electrical power, so what will be your formula? If you want to write this one for electrical power, do you remember that formula for electrical power? P is equals to P is
Work
equals
overtime.
to VI. Work over time is
Oh,
yes, it is.
because
Yes.
yeah,
Yes, because you know that for W we can just simply drive. Okay, I will also show the working of this formula, because in some questions for 1 mark they used to ask the question in this form, that drive the formula or drive the equation for P in the terms of W and Q, or in V in terms of voltage and electric current. So sometimes they ask you the questions like this, right? Actually, they are
yeah,
asking that write the steps how to drive this formula. P is equals to VI. Okay, so your derivation is very much simple. You just need to start with the basic formula. Power is equals to W upon T. Rate of doing work is known as power. And you know that work done is equals to, from the basic formula of potential difference that we discussed, V is equals to W upon Q is our formula, and we can just simply derive the value of work done from this formula, that is W equals to VQ, right? Or we may
yeah,
also write E in the place of V, because energy is mentioned over there. So we just simply write E over there because we are talking about electrical energy. So your formula will be P is equals to VQ over T. This is equation 1, our journal equation. Or we may also write V is equals to V into Q over T is the basic definition of electric current. I is equals to Q over T, right?
yeah.
From above equation, if we just convert Q over T into the value of I, so your final formula will be equal to P is equals to VI. So this is the formation of this formula. So if in any question they ask you to write the formula in terms of V and I and also show the working, so that is the working that you need to show in your exam, because in your AS, you also need to show that how we drive the formula for series combination of resistor, parallel combination of resistor, the formula of power, because there are two other formulas for power dissipation. If you remember with the reference of resistor, because one formula is P is equals to V square over R, and the third formula is P is equals to I square into R, right?
Yeah.
And that is related to the reference of resistor, right? If we are using resistor over there, so using the resistor means there will definitely a power loss over there, because resistor will never beneficial for us in the sense that that will increase the efficiency of the system. So that will always decrease your efficiency, because thermal energy in our circuit is no use for us. So that's why we just write the concept in this form, the formula for power dissipation. So whenever they ask about the concept of power dissipation, so it means that they are talking about the conversion of thermal energy from the concept of resistor or in form of resistance, right? So we can also drive that formula. Our journal formula is P is equals to VI. This is our original formula for electrical power. And if we take the reference from Ohm's law, so your Ohm's law is actually equals to V equals to IR. Again, substituting the value in equation number 1. So that will be P is equals to I into R multiplied by I. So your final formula is P is equals to I square R. Can see that resistance is included in this equation. It means that
Yeah.
of thermal energy. And second
Okay.
thing, if you want to write the same formula in terms of potential difference and resistance, So you have to apply the same Ohm's law, but in different form. Like this, again, we write the basic formula, P is equals to VI again. And now we need to substitute the value of I in this formula. From the Ohm's law, we know that V is equals to IR, but electric current will be equal to V over R. So if we substitute this value in your main equation, so your equation will be P is equals to V multiplied by V over R. So your final equation is P is equals to V R. So basically there are three types of formation of the same formula depending on the situation. If we are going to calculate power dissipation, second one, and if we are going to solve for the journal power, so then you need to solve with the reference of first formula, right?
Yeah.
So these are three formula that you already discussed and you already know about them. So there is nothing difficult in this situation. And it is almost the half of your first chapter. All previous knowledge is included. And I am just explaining again because this is a kind of revision, because maybe something you got out from your syllabus that was not you remember at that time. So that's why we are talking about these terms. And next quantity, you already guessed that we have to discuss about the resistance, right?
Yep.
So resistance, basically there are two types of definition, or we can say that we can explain resistance in two different forms. One is the conceptual one, and the second one is the uh, including the physical terms, right? The physical quantities, because we know that resistance is just like the friction. It is the hindrance in the path of flow of charges, right? So our next topic is related to resistance. So resistance, actually there are two types of definition. One is the conceptual based, that is simply it is the hindrance in the path of charges. And if you want to write the scientific definition, I'm writing it in inverted comma. So that is the ratio, resistance is the ratio between the potential difference and the electric current, right? Already know from Ohm's law, already drive this formula in Ohm's law. So that will also helps you to write the formula for resistance. So R is actually equal to V over I, and this is formula to find out the resistance. So that's why we write it is the ratio between voltage is potential difference electric current, right? And the next thing is the symbol. If you want to write the symbol for the resistance, so the symbol for resistance is capital R. And what will be the SI unit of resistance? They,
Of resistance ohms.
yes. So the SI unit for the resistance is equals to ohms, and the symbol is called omega. Symbol is for omega. That also be on our brand of the paint, because omega is also a brand, paint brand. So omega is the SI unit, and the symbol for omega is the symbol for ohms is omega, right?
Yeah.
And you also know that if we increase the value of resistance, the value of electric current will decrease. And if we decrease the value of resistance, so electric current will increase, right?
Yeah.
And all conductors have some value of resistance that is known as their internal resistance, right? If we are not using any resistor in a circuit, so there will be internal resistance of that conductor, right? So that
Yeah.
internal resistance is going to be included in our syllabus in AS. We also discuss that concept, and we also include the calculation of that internal resistance in our topics, right?
Yeah.
Any confusion till now?
No, it's very very much the same.
It's almost the same. We are just revising
The
because
drive was different. Only the drive topic was different.
only
But
the
the
derivation part is different, and that part of drift speed is different, right? Otherwise, almost, that's why I mentioned that 70 to 80% is the same. So it will be like we complete these two chapters in the same week, so you have enough material to solve and to practice from past papers, right? So that's why I choose these topics before, because if we start journal physics section, so all topics are interconnected and we have to solve all of them in a single go, so that will be more beneficial rather than solving in between some other chapters, right?
yeah. So how many lessons are there